Let me see.
Can someone at the back close the door, please? So we can get started. Okay. Good morning, everyone. Welcome to the LSR session. This is Yingzhen, and I have my co-chair AC online with me, joined remotely. As usual, we'll start from the working group status update. AC, go ahead.
Okay, I'm going to try and go pretty fast because there are some participants who wanted to see the first two presentations on flooding reduction enablement. So we're going to go pretty fast. This is the note well that you've all seen before. Basically, there's a number of documents, BCP documents, dictating rules for IETF participation regarding disclosure of IPR. If you know about it and you're participating in any way or form, you should disclose it. And behavior as far as being civil with fellow participants. So we'll go right on to the working group status. Okay. Okay, we've had one RFC, ISIS fast flooding. That work had a lot of consensus, but given that it had transport implications, there was a lot of discussion during both the working group last call and IESG telechat. We have two drafts on the queue, the OSPF admin tags and the Flex and the IGP Flex algo extensions for delay metrics and also the generic metric. The first one is good to have because there were a lot of extensions that required tags on prefixes other than external prefixes, and people were defining special purpose, either colors or tags and things. And now that we're going to have them on all types of OSPF prefixes, we'll be able to use those for that purpose. We have a lot of stuff going on with Yang models, so Yingzhen's going to cover them later. But we have these are all the drafts submitted to the RFCQ, not the RFC, the IESG. The prefix flags is just an extension. We were running out of flag bits. It's a backward compatible extension to allow for more more flags for additional features. We have the multi-part TLVs, which there's a lot of discussion on. If you're following the list at all, you'll know that that's to allow ISIS to send more information than will fit in a single 255 a single TLV that has or sub TLV that has an 8-bit length, and then reverse algo constraints that still has to go through the Gunter's review and IETF wide last call. We just adopted these two. I'm sure we'll have more discussion on those. These two, we've had requests to working group last call, the first one. And the second one, we were ready to working group last call it, but we started some other ones and it expired. But I still think we want to bring that back in working group last call it, the one on the algorithm related adjacency SIDS. Yingzhen's going to cover the Yang in more detail in a separate presentation. I don't think there's anything I'm going to say about any of these. Some of them, the last two, we really haven't had a lot of interest in those. I don't know if we need to refresh them. And these two, I'd really like to get that first one, working group last called. It's really needed for situations where you have like flex algos or something else, and you don't want to use a link or metric for a link in the default topology, but because of the way the encoding started and where we got to, you need to have the base topology and the base link included. So we'd really like that to be done. There's some other work that it needs to be done. The second one on the Anycast flag, we have it for ISIS, and I think we have it for OSPF v3. We just need to have it for OSPF v2. And it will make use of the prefix, the extended flags in the one draft that's already on the IESG telechat schedule. And that's it. Oh, yeah, we might, I don't know. We started talking about this at one time. There was a lot of discussion about the measurement of link loss, which is sort of ancillary. I know we did the delay metrics for TE. And I think that just needs to be scoped correctly in the draft, and maybe then we can adopt. Well, we could adopt it without that, but before we working group last call it, we have to make sure it's scoped correctly. How the loss is measurement and what the metrics mean. Okay, I'm done.
Okay.
I guess it's Shraddha first, right?
Yeah. Any
I guess
questions?
did anybody have any questions on the status?
Yeah. Any questions on status or agenda? Otherwise, we are doing a collective note taking, so you can join the note taker. I sent a link in the chat. Okay. So.
Yeah, so I will be presenting the flood reduction architecture. On behalf of my co-author. So we will see history and why new framework is needed and some details of how this distributed architecture for flood reduction works and some advantages. So this distributed flooding architecture, it is first published as part of the distop flood reduction algorithm. So it's also presented in IETF 120 and 121. And working group suggestion to move the architecture to a separate document. So this time what we have published is just a split of that document, the architecture into a new document. And there was also discussion on the mailing list and working group consensus to work on the distributed architecture for flood reduction algorithms. Yeah, a quick recap on why new framework is needed. Again, all this was discussed on the mailing list. I'm just covering it here again for people who are looking at it for the first time. So, so people would like to introduce this flood reduction algorithm in parts of the network. And if they realize that this is working well and giving them good flood reduction, and then they probably want to increase its deployment to cover the entire network. And also ability to upgrade it to a new version of the algorithm part by part. Or in future, like 5 years down the line, if there's a new algorithm, new flood reduction algorithm, which promises better more reduction, they would want to follow the same mechanism to upgrade their network to the new algorithm. So, so basically people are looking for a way to migrate their network to the to enable flood reduction in part by part or node by node basically. So this gives a lower risk of operational mistakes, because if there is a single node that is able to control what flood reduction algorithm runs in the network, if some mistake happens or some misconfiguration happens, there's a possibility that the entire network switches from one flood reduction algorithm to another flood reduction algorithm inadvertently, which is not really intended, and that poses some risks. And so there is a interest in developing a new framework which will allow slow migration of the network from one flood reduction algorithm to the another. So we look at some of the terminologies this distributed flood reduction architecture uses. A pruner is a node running any flood reduction algorithm. And a zero pruner is a special case of a pruner, which is flooding on all the interfaces, which is basically means today's flooding. Connected component is a set of nodes that run the same pruner that have at least one path connecting all nodes in the set. And then there are some, you can see some notations, how that is, the document uses these notations to denote connected component. P pipe, and then if there are two disjoint sets of the same pruner, like there's one set and then there is another set which are not connected, then they are denoted using P pipe quotes and P pipe double quotes. And then there is connected dominating set, which is basically a connected component which has one set of paths, one path that connects all these nodes in that connected component. So it's basically a flood reduction applied on that particular connected component. So once we know, understand the terminology, right? The flooding pruner procedures that this architecture defines is very simple, right? There are basically 3 rules. So every pruner must advertise the pruning algorithm it is currently running. What algorithm it's currently running, it must advertise. Every pruner is allowed to run only one algorithm at a time. So it must say which algorithm it is currently running, and it has to be just one algorithm. And a node that is not advertising a pruning algorithm is assumed to be running a zero pruner. So those are the 3 basic rules of these procedures. And then there's a simple procedure to, what the pruner will do when it recognizes another node is running a different algorithm, right? So a pruner, any algorithm that adheres to this framework, so it must prune links for flooding only within its own connected component. Like it should look at all the nodes that are running the same pruner, and it is allowed to reduce the flooding or choose the selected links only within its own connected component. And a pruner must flood on all links outside its connected component. So basically, if a pruner finds a neighbor is running a different algorithm, it must flood on the adjacency to that neighbor. So basically, these are the only 2 rules that are required to adhere to any algorithm that operates in this framework. And a third point is that there are further optimizations possible if the neighbor is running a zero pruner. That is, if you know that it is not doing any pruning, it is flooding on all its links, then it can do further optimization, but that is left to the framework doesn't define whether that is to be done or not, that is not to be done. It is left to the individual algorithm to define how that optimization can be done. Yeah, that is one example. So you see the red nodes are running the pruner algorithm P1. The blue nodes are running the algorithm P2. And the border, like 3, 4, 5, and 6 are the border nodes that, like, for example, 3 figures out that 5 and 6 are running different algorithms, so it must flood on both the links. Similarly, 4 also must flood on both the links connecting 5 and 6. The other direction is also true. 5 and 6 flood towards 3 and 4 on both the links. They cannot prune those links for flooding. So within its own component, like 1 and 2 and 7 and 8, they are running within their own connected component, and they are allowed to prune the links for flooding. So we need a protocol extension to say which algorithm a pruner is running. So this is what is the proposed extension. So sub TLV of a TLV 242, and so there is an algorithm and there is a version. So algorithm is a numeric identifier in the range 0 to 255 that identifies the algorithm and for calculating the CDS. So when we wrote this, we have taken the full range 0 to 255 because we were thinking we will go with the new registry. But that's something I think I do hear that people have other opinions. So that's something to be discussed. And then there is a version. So it's the same algorithm, a different version. Then you can advertise a version for that algorithm. So whether the different versions of an algorithm are backward compatible or not, whether they are considered as the same pruner or different pruner, that is defined by individual algorithm itself. Yeah, so some of the advantages. So within the connected component, they are free to use any algorithm, and the pruner itself can be centralized or distributed. And it just has to advertise what algorithm it is running. Really no other configuration is required. So when a node decides to change the pruner algorithm, like a new pruner algorithm is enabled on a node, its adjoining nodes are affected and not the entire network. So a node by node deployment or migration is possible. Yeah, we request for review and comments, and also request working group adoption. Any questions?
AC, please go ahead.
AC Linda Labin. I just had one question. So you would always have separate connected components if either the version or algorithm were different, right?
So whether a different version of the algorithm is a different connected component or same connected component, this is defined by the algorithm itself. So the framework doesn't define whether they are same or different.
Okay, so they would always be different for sure if the algorithm were different, but not necessarily the version. It depends on what kind of the semantics of the algorithm, right?
Yes. Yeah, right.
Okay, and if they are the same, then they'd always be part of the same connected component as long as there were two routers that were adjacent to one another, right?
Right.
Okay, that's the way I interpret it. I just want to make sure.
Keaton.
Ketan Talaulikar, Cisco. Could you please go back to slide 6 or 7? I had one question there. The zero pruner, I think.
This one?
I think the one, yeah, the next one perhaps. Okay, but the zero pruner. My question was about a zero pruner.
Yeah.
Does the framework assume that a zero pruner is going to flood on all its links?
Yeah, yes.
So let's say if we were to consider a deployment where there are mesh groups configured, a mesh group is not by definition a zero pruner.
Right.
Is that correct? Okay. So let's say an operator is migrating from a mesh group to a flooding reduction, they would need to turn off the mesh group or take it out of the disable mesh group, let's say, go back to default and then change over, something like that?
Yeah, so that is one option. I think that's something that we need to discuss, right?
Sure,
So that is one option. The other option is maybe mesh group can advertise. We can allocate a algorithm for mesh group, and it can advertise it is running that algorithm. Or the third option is you have a configuration possibility. Let's say the mesh group is deployed, you're not going to upgrade that node and you want to introduce the flood reduction algorithm different part of the network. You could also do that. You could also say on every neighbor that, that this, you must flood on this, have an option of explicitly configuring that you must flood on these.
Okay. Yeah, I mean, sure. It was just a question. I think we need
Yeah, so
to
this
further
needs to be
discussion.
discussed. Yes.
Sure. Thank you.
Agree.
Hi, Tony Lee, Juniper. I wanted to talk a little bit about a comment you made about versions. If you've got one algorithm with two versions, how do you make things backward compatible? Version 1 may or may not interoperate with version 2, and I don't think you know that. And so I think you have to consider them separate components.
Yeah, so the idea is that the algorithm itself defines whether they are backward compatible or not, version 1 and version 2, because it's possible that you have a version 2 which is backward compatible with version 1, or you could have a case wherein they are not backward compatible. So this is basically defined by the framework. The framework defines that if there are different algorithms, you must flood it. But whether the version, same algorithm, different version, whether it belongs to a same component or not is defined by the algorithm itself.
So the point is that you can't know whether you're going to be backward compatible when you're doing version 1. And so you're going to have a little bit of an issue here. And that means that if you want to do something that isn't going to be backward compatible, you have to go to a new version number, which means we're blowing up and wasting version code points and burning the top level version numbers. It actually probably would be simpler and gentler if you just made everything separate components. But we can talk about this offline.
Yeah, sure.
Tony P., you are the next. Tony, can you hear me? Please go ahead.
Yeah, sorry, multiple buttons. I hope my mic is working fine. Last session I had some troubles. So actually I want to comment on these mesh groups, but I think I put it on the chat. And what Tony said is actually correct. I don't think the versions will work because if you deploy one, you don't know whether two will be compatible or not. When you deploy version 2, you will know that one was compatible, but it doesn't help you. So that may be a non-starter. But good to take it to the list of talking through. Thanks.
So Martin here from an operator. I just have one comment. What I like about this architecture is that it works with very minimal additions and modifications to the overall protocol. Thanks.
Thank you.
Any other questions? No? Okay, thank you. So we'll go to the next presentation. Les?
Yep, can you
have
hear me?
control of the slides. Yes, I can hear you. Please go
Okay.
ahead.
And oh, okay. All right. So Peter and I put this presentation together. Here's the agenda. I've deliberately put a pause in the middle because I think the first few slides are probably the things that are going to generate the most discussion. Hopefully we'll have time to discuss the remaining slides, but I want to make sure that we got some discussion on the first few. The relevant documents here are the flood reduction architecture and dis.flood and the existing RFC. I'd just like to emphasize that the presentation here is not objecting to any of these documents. We're just trying to raise concerns that we have about leaderless operation and also discuss some encoding/operational issues. As a matter of perspective, the update process, or flooding, if you will, is sort of the crown jewel of link state IGPs. And a big reason the link state IGPs have been so successful has been because the update process is 100% reliable, not 99% reliable, but 100%. Nevertheless, in the history of the protocol, even though the initial specification of the update process was excellent, we have found a few issues over the years. I'm not going to spend time digging into them. I just want to point out that with something as complex as flooding, that there are always things that come up that we just don't anticipate. This is probably why we've been talking about optimizing flooding for 25 years, but until very recently, we've stuck with some very modest improvements, mesh groups, suppressing flooding on parallel links. And it's only in the last couple of years that we've actually tried to move forward with an optimized flooding algorithm. And recently, of course, the RFC talks about a leader-based, and now we're contemplating potentially leaderless. So one of the points that I want to raise here is, what's the motivation for leaderless? I think the arguments that have been stated in the discussion that's taken place in the working group thus far have been based principally on two things. One, the viewpoint that it's easier to deploy. I'm going to present some things that suggest that's not really the case. And the second argument has been made that with a leader-based, you have a blast radius problem. That is, that it's unavoidable that a significant part of the network is all going to change with the flip of a switch on one node. That's not necessarily the case. I think this has been very misunderstood. And so I think the point that we're trying to raise here is the real motivation for leaderless seems to me to be whether there's a deployment requirement that we're going to need to run different algos in different portions in different subtopologies of the network. So, is this a real deployment requirement? And there are definitely some issues at some point where you might want to transition from one algorithm to another, but there are risks associated with doing so when you use leaderless. So here's a little comparison between leader-based and leaderless. What we tried to do here is the things that are marked in green are somewhat of an advantage for that approach, and the things that are marked in red are somewhat of a disadvantage. I'm sure people have some different opinions here, but just briefly going through the points. For both leader-based and leaderless, there is per node enablement. I'll spend a little more time discussing that on the next slide. So there's no difference here. For a leader-based, yes, we do have a leader election. It's based upon a well-known process that is already deployed with widely deployed with FlexAlgo. But in leaderless, there is no election. So, okay, that's a plus for leaderless. With leader-based, you're guaranteed that there's no more than one optimized algorithm operating in the network at a given time. With leaderless, multiple algorithms can be enabled. This could be done intentionally, or it could be done accidentally as a result of some misconfiguration. And there is risk associated with that. For leader-based, a given node doesn't care whether any of its neighbors are running an optimized algorithm or they're not, or they're just using base flooding. But for leaderless, the nodes that are running an optimized algorithm need to know what algorithm their neighbors are running. And I think this was clearly explained by Shraddha in the previous presentation. If you need to do a transition from one algorithm to another algorithm, with leader-based, you basically have two choices. You can revert back to base flooding and then move to enable the new algorithm, or you can risk a flag day. With leaderless, if you want to transition from one algorithm to another, you can enable multiple algorithms in the network at the same time and gradually move from one to the other. But you have a period of time when you are running multiple algorithms that comes with some risk. And the last point to me is one of the most important. How do you test what you're going to deploy before operators actually start to deploy it? With a leader-based, your test matrix is very well defined. You only have one. There are two possibilities for a node. It's either running base flooding or it's running the optimized flooding. And this can be tested. With leaderless, you have the potential for multiple algorithms running in the network at the same time. The ability to do that kind of testing is troublesome because I might implement, say, dist-up flood today and deploy it, and there's no other optimized algorithm that's currently on the standards track. And somewhere down the road, another algorithm becomes standardized. How do we test the two of them? The vendors that have implemented the first algorithm may not have implemented the second algorithm, and vice versa. There are definitely challenges in trying to do that kind of testing. And again, as history has proven, despite our best efforts, subtle issues may arise, and therefore the complexity of supporting multiple algorithms in the network comes with some risk. So the conclusion I want to draw here, and I'm sure this will draw some comments, is that the compelling reason to go to leaderless is because people think that they actually want to deploy multiple algorithms in a single area. Okay, one more slide and I'll pause. I want to talk about the blast radius. What's been stated is, oh, well, with leaderless, you do this one node at a time, but with leader-based, you're going to flip something on a leader, or the current leader dies and a new leader takes over, and all of a sudden the whole network converts. This is not the case. If you have an intelligent implementation of a leader-based deployment, there are two things that are required in order to have an optimized algorithm enabled on a given node. One of them is that the elected leader has to say, okay, algorithm number 2 is the algorithm that can be used in the network. And you have to go to each node and say, I'm enabling the use of algorithm number 2. Anybody who implements this where the nodes just blindly follow what the leader says without local configuration has done a substandard implementation. That's something that they should correct. So the conclusion here is that the blast radius for the leader-based and the leaderless are the same, one node at a time. I'm also illustrating here in the table that what action is taken. If I do local enablement of an algorithm with leader-based, the neighbors don't care because they know that they don't have to make any changes, that their neighbors are either running the same optimized algorithm as they are, or they're running base flooding. But with leaderless, the neighbors have to learn, oh, you're now running an optimized flooding algorithm. I need to know what it is so I can decide whether you're running the same algorithm as me or not, which will affect how flooding is enabled on those links. Okay, again, this was clearly illustrated in Shraddha's presentation. Same thing's true for remote enablement, the enablement of an algorithm on my neighbors. Okay. So let me pause. And I guess, Tony, you're first.
Hi, Tony Lee, Juniper. I've got a lot to say here, so please bear with. First off, for those of you who haven't been paying attention, I'm the guy who originally proposed the leader model. And I've been talking to operators about it for, better part of 8 years now. And they've had one thing quite consistent to say: no, thank you. We don't want a leader-based election. Whether they are correct or not, they are unwilling to accept it. We kind of need to accept that this is market reality. Whether we like it or not, operators are not going to deploy leader-based election. Okay, now let's talk about all of the points on Les's slides. Could you please back up 2 slides? Right, per node enablement, absolutely true. Leader election, same as FlexL goes. Designated DIS election, no question. Leader-based, absolutely. There's only one algorithm per area. This is a problem, okay? We might not have our algorithms right. Being able to change from one algorithm to another in a smooth and gentle manner is a big win operationally. Yes, of course, we need to be able to change, and the leader-based election can change, but it's not a gentle change. And that scares people. It may work, it may not. It should work. I happily stipulate it should work, but we can't guarantee it, and that is very scary to people. About the behavior of neighbors. It's true that leader election, you don't have to read your neighbors' TLVs to figure out what they think they're going to do, because you just have to listen to what the leader says. But you're assuming that your neighbor is listening to the leader and is complying and has a working implementation just as well. So yes, there's a little more information you have to get to, but the assumption is that your neighbor is going to interact nicely regardless. The test matrix. If you've got 2 algorithms, there is no real test matrix across algorithms. Okay, in a leaderless election, you have 2 separate subgraphs, one running version 1, one running version 2. All the links between the 2 subgraphs are running full flooding. So that just means that the algorithm has to work by itself within its own subgraph. So if your algorithm works, it works, and if it doesn't, it doesn't. There's no real problem here. As to next slide, blast radius. This again goes to the transition. Let's suppose we have version 1 of our algorithm running right now, and we want to transition to algorithm 2. Here's the problem. The ISP has been running version 1. Let's say they've had it up for years and they're pretty happy with it, but version 2 is coming along and maybe it's better in some way, or maybe version 1 has a bug. Either way, they've tested version 2 in the lab, they've played around with it, and now they want to actually deploy it. Okay, they've deployed new code on all the nodes, and now they're ready to change the leader so that it indicates version 2. Okay, here it is. We got a maintenance window. We're going to cut over. We're going to go to algorithm 2, and suddenly either algorithm 2 works or it doesn't. It's binary for the entire area. That's scaring people. I'm done.
Okay,
Les?
Tony, just a couple of responses because I want to let other people chime in. But in terms of in leader-based, the reason a node doesn't have to care about what its neighbors are running is because the node knows that there's only 2 choices. It's either running the same algorithm as I am, or it's running base flooding. And because of that, whether that neighbor changes behavior from one to the other doesn't affect what links I flood on. Okay. The other point I would like to make, and I fully agree with you, that transitions are, shall we say, more difficult with leader base, but nobody today has run two algorithms in the same network at the same time. And how we go about testing that is still, I think, a very open question. So I agree with you that transitions can be difficult, but to say, because in leaderless, all I have to do is run two algorithms and enable the second algorithm node by node by node, doesn't mean there's no risk here.
So there's always risk. The question is, how much risk do you want to take at any one time? The nice part
Yeah,
about the
and
leaderless
what I'm-
approach is that you get to upgrade one node at a time, very gently, sit and relax and let it soak in, okay? Soak time is a very important thing, and any operator will tell you, you make deployments very slowly because you don't want to try to change everything all at once. That's a good way to get yourself finding a new career.
All right, I'd like to hear from more people, so.
Tony P, please go ahead.
Okay, I hope you can hear me. Hey, Les.
Hey, Tony.
So, yeah, as a minor observation, if you go back to the mailing list on my triangle example, you will see that even if you run a leader distributed, the nodes have to know that the neighbor is running the same thing. It's a minor thing, though. So I'm acknowledging, your perspective here, right? Which I think we discussed quite extensively back and forward on the mailing list. And, things have been partially clarified, partially refuted, partially, people agree to disagree, whatever. For me, the main thing is that we kind of have had a working group consensus to work on the leaderless stuff, right, as an option in some form. And hence, we can rehash those things. We can go back to mailing lists. We can basically go in circles for a bit. But I'm kind of looking forward to the second part of your presentation, where we start to talk about some, suggestions how to actually address the problem to provide a leaderless option, even if people at the end, choose to run into leader base for one reason or another. But I mean, you heard Tony Lee's perspective, right? And I had also some discussion with him, and as usual, he's very close to customers. And I think it's an important point that we have to address market realities. Because otherwise, whatever we standardize will have, just museum status. All I had to say. Thanks.
Okay, thank you.
We have seen several arguments why people look into leaderless architecture. But I think there's one another argument that makes at least me a leaderless protocol. Just selecting a leader does add some complexity in the protocol. And actually also just recently, we did have a bad experience with other protocols that do similar things. Originally, I thought, yes, that's simple, easy to manage, but just recent observation and experience showed us it does matter. Complexity does matter, and just this kind of complexity did cause us serious outages in some other protocols. So this is, from my point of view, a very serious argument to look for leaderless operation. Just to add to some other discussions here, I don't think we need a lot of different protocol algorithms. I don't care about what exact algorithm here or there. I don't think we will go to change algorithms frequently. And I don't even think it's easy to change an algorithm, but I actually want just one better algorithm than the one we currently have.
Okay, thanks.
Hello, I'm Shraddha Hegde from Juniper. So I had a point about the test matrix. I think Tony already covered it at a high level, just wanted to add more to it. So the multiple algorithms and testing that, it says it is unbounded, which is not really so. So you have to test that within your component, your algorithm works fine, and then on the borders, flooding on all the links, right? And if both algorithms do it correctly, the flooding graph would just be fine. With the complexity of testing flooding, right? It is complex, whether it's one algorithm, two algorithms, or even existing algorithm like today's no optimization, right? Just flooding everywhere. Even testing that all scenarios is quite complex, right? There are bugs which are sitting for many years, but they get discovered in a particular scenario in a particular network. That's what we see. That's our experience, right? So when it is when testing the flooding itself is so complex, and there are it is possible that there are some bugs left, and if you have a way to slowly introduce it in the network, then your risk is less, because if you find a bug, it will affect the first that you deploy it on, and not the entire network. And so that's exactly the reason why you have to have a mechanism to slowly introduce, right? So that your risk factor is much lower.
So Shraddha, just to clarify why I say the test matrix is unbounded, it's not just a matter of, well, enabling a second algorithm on some set of nodes and seeing how it interoperates with another algorithm. It's also, where are the touch points? What are the topologies? As one thing you and I agree upon is that flooding is complex, and it may work in a lot of scenarios, and then we get into some particular topology mixture, and we find that, oh, there's a bug here that never showed up before. So that's why I'm saying the test matrix is unbounded. It's not just, oh, let's enable algorithm 1 and algorithm 2 in various subplaces. It's also, what are the topologies in which these things interact?
Let's just one clarification, right? So what you call unbounded, if you call that as, some mix of topology, it is probably, doesn't work. So that's why it is unbounded. That is true for any flooding. That's true for today's flooding as well. So I don't agree that, you have to call one as very well defined and unbounded. That was my point. Thank you.
I guess I'm up. AC Lindum, Lab in again. I was just going to say that, in Monet, there are a lot of different flooding reductions. There most of those, both in the OSPF and May extensions and in the May protocols themselves, there isn't a fully redundant flooding. Now, so you have these communities where there is an optimization, and those can be toasted. They can be toasted if they work. They can be tested. They can be tested in isolation, and then you can have and then the flooding that goes back to the base protocol flooding, where you flood all the time in between those domains. And I think it all works. I don't see why you can't test those in isolation and connect them similarly, that you can test any algorithm within the domain which the algorithm is scoped. like a lot of times, you can have a completely reliable flooding in that's scoped on a single interface, where you just use multicast and don't do the retransmissions, and you can completely test that within the scope of one subnet and not worry about anything. So I don't think worrying about all the combinations between algorithms, as long as you test that where there are different algorithms, you're flooding, I won't say without any, I'll use Tony's terminology and say without any pruning. I think your testing matrix is fine.
Okay, thanks.
Yeah.
Peter Pshenak, Cisco. So Martin, just for your complexity thing, I think picking up the algorithm is of no complexity compared to what we are doing here. We are going to change the very basic functionality, and the bugs are not going to be in selecting an algorithm, probably in the flooding itself.
Doesn't match to my experience.
Tony Lee again. I wanted to speak again to what Les had to say about the test matrix. Yes, there are an infinite number of graphs available, and testing an algorithm on arbitrary topologies requires a lot of testing. Yes, I have done it. But we know that because there are only so many ways of putting things together, and if you look at, say, the four-color theorem, there are only so many different types of graphs that you can get to. And so while testing a particular algorithm is unbounded, it's not going to be infinite. Okay, we're not trying to test every single possible graph. You just have to test enough graphs so that you know your algorithm works. Once you have two graphs or two algorithms that you have individually tested, then the intersection between an operation between those two algorithms is not an issue. Again, the boundary between those two algorithms is full flooding. Yes, you have to test algorithm 1 versus full flooding on its boundary. That's easy to do. You have to test algorithm 2 versus full flooding on its boundary. That's also easy to do. Once you have both of those working, there should not be an impact, because you never, ever should have an interaction between algorithm 1 and algorithm 2.
So Tony, if I might, this strikes me as the debate between theory and practice. So in theory, you and I are in complete agreement. In practice, I'm not so sure.
Well, you and I both do both, okay? So
Yep.
in practice, we have not seen a problem.
Actually, we have. That's what I documented earlier, that we have seen problems even with base flooding. Sometimes it took us years before we saw it, but we have seen them.
We have not seen problems with flooding algorithms trying to interoperate with other flooding algorithms.
Well, sure, because we've never done it.
Les, you're typing, and every time
No,
you type,
I am not typing. Somebody else
okay,
is typing.
somebody else is typing. Whoever it is, your mic is open, and every time your
AC,
mic picks up, it cuts me out.
AC, I think it's you.
I confess, I'm trying to take some quick notes here, and I forgot to mute my audio after speaking. I could use some help with the notes.
Okay. Yingzhen, do I have time to continue or not?
Yeah, you can continue.
Okay, so I wanted to touch on version versus algorithm. So the distop flood currently has this definition, where says it says there's a sub TLV, and it's going to advertise the version. If I interpret this correctly, this means for each algorithm there would have to be a new code point invented, because the TLV type itself doesn't, the TLV doesn't advertise the code point. In the flood reduction architecture, there's a definition that looks like this, which has type, length, algorithm, and version. At a minimum, these two things need to be reconciled. I would personally vote for taking the sub-TLV out of dist.flood. I don't think the algorithm needs to define it. I think the architecture needs to define whatever we're going to do. So we've talked about upgrades and versioning. I think there's a couple of cases here to look at. If you're going to upgrade to a new version of the same algorithm, and I think Tony Lee's really, touched on this already, you've got two cases. Either the upgrade is backwards compatible, in which case you don't actually need to advertise a new version. You can just deploy a mixture and there should be no problem. Or the upgrade is not backwards compatible, in which case deploying the new version is equivalent to deploying a new algorithm. So I don't see the benefit to using a version. The second case is there's a bug. There's two places you could have a bug. You could have a bug in the specification that, okay, despite our best efforts, we specified the algorithm and there was something that we missed. This to me is just an instance of case number one above. Either the fix is backwards compatible or it's not backwards compatible. The other case is somebody's implementation has a bug. The specification is fine, but their implementation didn't follow the specification and under some set of circumstances. Clearly, there's no way to usefully define vendor-specific versions and build some interoperability matrix. So to me, I just don't see that version is useful. As far as advertising the algorithm, this is the sub-TLV that's currently defined by the RFC. It has a type and length, and then it has potentially multiple algorithms. This sub-TLV is not intended to advertise what a particular node actually has enabled at the moment. It is meant to advertise the algorithms that the node is capable of supporting. But leaderless nodes clearly need to advertise what algorithm they're actually running. So I think what we end up needing, and because potentially, I don't know where the working group's going to end up. We're talking about leader-based, we're talking about leaderless. We could end up saying, all right, we're going to define ways to support both, or we're going to arm wrestle until one of us wins. But I think if we advertise something that looks like, here's the algorithm that is currently enabled on my node, that I think this works for all cases, both for leader and leaderless. And we could argue about whether there should be a new sub-TLV or some repurpose of the current sub-TLV in 9677. Tony, you want to jump in here?
Yeah, I'll respectfully disagree. I think that actually it's having the version number is actually helpful. Oh, I'm sorry.
Despite what you said earlier?
No, I didn't say it wasn't useful. I said it needed to be orthogonal, so the version numbers are not backward compatible. I think that gives us basically 2 octets to play with, and I think that would be a good thing. I would opt for 2 separate sub-TLVs. That way, it's very clear what every node is doing. And then the interesting question is, okay, what if somebody's advertising both? What do we think that node is doing? And I do think we need to have a rule that says one of these predominates.
Okay. Okay, as far as the registry, there's an existing registry currently that's defined in RFC 9667, which looks like this. Zeros reserved for the area leader, and then 127 for standardized and the space for private. I don't see why this isn't sufficient. I think we can continue to use that. And now we get to the use of periodic CSNPs. This is something that's been recommended for many, many years as an aid to reliability. It was recommended when mesh groups were introduced, just as a fail-safe. Hey, if something goes wrong, the periodic CSNPs will make sure that we recover in a modest amount of time. I think this works pretty well at modest scale. But at high scale, and I think these are the deployments we're talking about because that's where we really need to use optimized flooding. The number of CSNPs that you need to send to describe the entire LSP database starts to explode. So here's just a quick calculation based on a 1492 byte MTU, which is the typical default. If you've only got 1,000 LSPs in your database, 11 CSNPs suffice. But if you got 10,000, then you have to send 108, and you can do the math from here. There's some discussion in the Distop flood draft about targeted PSNPs. It's sort of remembering what LSPs have changed in the last few seconds. And if you need to, if you haven't gotten acknowledgements, maybe you send the PSNPs, which are then, typically one PSNP would probably suffice under most circumstances. I think this is an attractive alternative, but we need to discuss this more and sort of specify what kind of timing we want to use so that we don't actually undermine the flooding optimization itself. But I'd like to see this topic explored more. Okay. Yingzhen, how am I doing on time?
You have 10 more minutes.
How many?
10 more minutes.
10 more minutes. Wow. I feel just so.
But that includes that includes the discussion too.
Yes.
Yeah.
Yeah.
Okay. But all right, let me just go through this. I think that'll still leave time. So we've talked about mesh groups. I think we probably have not talked about them enough. This is something we should dig into going forward. I think the way I look at mesh groups they're a static flooding algorithm. And it may be useful to have a node announce, I think Ketan mentioned this earlier, to say, hey, I'm using mesh groups, so maybe we could reserve an algorithm value for it. I don't think trying to describe, that is, what links are blocked by mesh groups and what links are enabled by mesh groups. I really don't want to see us go down that road. I think that introduces some if you're worried about complexity, the advertisements you're going to need to accurately reflect that are going to add complexity, and I'm not sure what, if anything, the optimized flooding algorithms could do with that information. So I think beyond advertising, hey, I'm using mesh groups, treat me with caution. That's probably as far as I think we should go. And otherwise, it's up to operators, as it always has been with mesh groups, to do this very carefully. And I think I'll stop here. I don't think the last two slides are as important. So, Tony P.
Yeah, hey, Les, Tony P. Juniper. So, from this press on the mic with some sketchy PowerPoint, intriguing proposition, right? I do not take upon myself to decide, whether there are any holes in it will work or not work. It's 4 a.m. here. And inventing this kind of stuff on the mic mostly leads to suboptimal standards. But I think it would be good to get it down to some serious discussion after the stuff has been written down in some form or fashion, so we have framework to discuss it in detail. An optimized way, it's the adopted architecture thing that we suggested, that people decide we start to a new individual or something, all fair game. You're correct on the TLB included in the this topo stuff. The idea is obviously that once something gets adopted that provides this running algorithm TLB, that this topo will basically fall back onto that. That's kind of evident. That's all. Thanks.
Okay, thanks.
Hi, Tony Lee, Juniper. On the number of CSNTs, I will respectfully disagree. CSNTs are a wonderful parachute, and I would not encourage disabling them in any circumstance whatsoever. However, I am sensitive to the point that they are only buying us a single level of reduction. I will point out that there are other techniques. For example, one could also digest your CSNPs and have a second level of reduction. I would be happy to explore that, especially for a large LSTB. That would make a great deal of sense. I've seen that technique used in other circumstances. It is absolutely helpful. Next slide.
This one?
Yeah, mesh groups. So back on mesh groups, I disagree that we need an algorithm value for it. We already know that any node not advertising an algorithm is doing legacy flooding, and that includes mesh groups.
Not true for leader-based. Leader-based nodes do not advertise. The only node that advertises the algorithm in use is the leader. The other nodes don't advertise what they're doing.
Okay, fair point. That you probably should add that to this slide.
Okay, I mean, I mentioned it in an earlier slide, but okay, we're in agreement. That's good.
Okay, that's all.
As far as the second level CSNP, I'd certainly be interested in looking at that as an alternative. We have already seen with a large number of neighbors that sending CSNPs has its own scaling issues. So I think we need to do something about it.
Okay. Any more questions?
AC,
you
are you
want to
back
say something?
in the queue?
Yeah, I just wanted to comment to Tony Bragenda that you could go ahead right now and take out the encoding from the flooding algorithm, the distributed flooding draft. And then there wouldn't be, then at least there wouldn't be any confusion if it's still in there. I hadn't looked at it once. I didn't even know it was still there. That's all.
Well, because we have not in the working group that can carry it, right? We need something about the working group that has the TLD we can fall back. Otherwise, how is an adopted draft supposed to rely on something which is an individual draft?
Right,
but
okay. But
Okay. Any more questions? If not, thank you for all the discussions. We'll go to the next presentation.
I was just gonna say you could use the leader based until then, we're to and still make it a pure algorithm flooding reduction algorithm draft, Tony.
Yeah, it's just that
we hack it. Don't forget it. I mean, the semantics of the stuff is it's the supported one, not running, and they can carry multiple. Of course, we can hack any TLB to mean something else in our draft. I consider that a very bad taste. That's why the stuff is where it is. Thanks.
Yeah, and AC, I'd just like to point out, this was mentioned earlier, the meaning of the advertisement as it's currently defined in the RFC is not what a node is running, it's what a node is capable of supporting. So trying to use that to advertise what's actually enabled is changing the semantics of it. which is an option. We could discuss the possibility of doing it, but it's not without its own risks.
No, I think we're going to do an adoption call on the leader lists because it seems like there's a lot of interest in it, and work out the details once it's adopted. We can take it to the list, though. I think it's, rather than doing it in 2 steps, I prefer, speaking as chair, to do it in one, though, and just do the adoption.
Yeah, so I suppose we'll have more discussions on during the adoption call and take everything to the list.
Mhm.
So, okay, so now let's go to the next presentation.
Can you hear me?
Yes.
Yes, I can hear you. And you have control of the slides.
Okay. This is Chang Wanlin from H3C. I will present this draft on behalf of our co-author. This draft is about the IGP extension for advertising reverse prefix metric. So background, the strict RPF checked process involved verifying that a packet is received on the interface that matched the router's reverse path to the source. But in the following scenarios, the strict RPF check will fail. The scenario 1 is about an asymmetric cost network. As shown in the diagram on the left, the next hop for the router from the router 1 to P4 is interface 1, with the forwarding path route 1, route 2, and route 4. On the other hand, the forwarding path from P4 to route 1 is route 4, route 5, route 3, and route 1. The forwarding path and the reverse path are not the same. The second scenario is about any cluster network. As shown in the right diagram, the forwarding path from route 1 to P is route 1, route 2, while the forwarding path from P to route 1 is route 3 and route 1. As well, the forwarding path and the reverse path are not the same. Therefore, if the cost between the forwarding and the reverse path to the source is inconsistent, the strict RPF check will fail, result in the packet being discarded. So, IGP advertised the link information through the link state database, which provide both forward and reverse path costs within the IGP domain. So the reverse SPF calculation can be performed with the node containing the source address as the SPF router to obtain the reverse ingress interface. However, in an IGP multi-area network, the reverse cost across areas cannot obtained from the IGP LSDB. Early alternative is to add the incoming interface for all ABRs advertising the prefix. Now, let's explore why the reverse prefix metric is necessary. As shown in this diagram, there are 2 areas, route 2 and route 3 as ABRs. ABRs generate the inter-area RC. The inter-area RC only include one-way cost. For example, Loud 2 to loud 4 cost is 10. Failing to reflect the reverse cost. For example, loud 4 to loud 2 cost is 100. Such lead to inaccurate RPF checked, where the packet potentially arriving from incorrect interface. Based on the actual cost, the packet from P4 will reach the loud 3 through loud 5. The real incoming interface should be interface 2. So this document defined the reverse prefix metric TLA, which can be used to advertise the reverse metric information when IGP advertised prefix information. Let's take a look at the extended TLA for IGP. In ISS and OSPF, we have defined the reverse prefix cost sub-TLA. For ISS, the reverse prefix cost sub-TLA can be included as a sub-TLA within TLA 135, 235, 236, and 237. For OSPF version 2, the reverse prefix cost sub-TLA can be included as a sub-TLA of the OSPF version 2 extend prefix TLA. For OSPF version 3, the reverse prefix cost sub-TLA can be included as a sub-TLA of the inter-area prefix TLA. Finally, we can see an use case. First, on the ABR, a reverse SPF calculation is performed. Taking P4 as an example, the process is as followed. For the ABR loud 2 and loud 3, calculations are performed with loud 4 as the SPF router. The reverse cost from loud 4 to loud 2 is 100, and the reverse cost from loud 4 to loud 3 is 15. And then next on the ABR, when generating the inter-area LC, the reverse prefix cost TLA is added. On the loud 2, when generating the inter-area prefix LC for prefix 4 in area 1, the cost is 10 and the reverse cost is 100. On loud 3, when generating the inter-area prefix LC for prefix 4 in area 1, the cost is 14 and the reverse cost is 15. Finally, on loud 1, when performing a reverse SPF calculation with loud 2 and the loud 3 as the SPF routers, it did made the ingress interface for the prefix 4 is the interface 2. That's all. Thanks. Any question come, welcome.
Peter, please.
Peter Pshenak, Cisco. So I just want to point out there is already a solution for this. We have defined, or there is a draft for reverse SPF algo. And if you combine it with flex algo, you are going to get exactly what you want. The metric that we advertise for that algo would be a reverse metric. So I don't know whether we need a solution for algo 0, and then, we have a native way of doing it in flex algo. I just want to point out that there is a way of achieving what you're trying to do.
Yes, the reverse flex algo is deployed across the entire network. Our draft address the scenarios when the IGP advertised reverse prefix cost in non-flex algo networks. such as which can apply for RPF or multicast use case. Thanks.
Li Bin Liu from Zhongguan Lab across all this draft. I think explicit reverse path calculation of the prefix is useful in many cases, not only for the improving the strict URPF to prevent to avoid improper block or legitimate traffic and prevent swerving traffic. It is also useful to optimize the traffic engineering and the network planning based on the past information. Thank you.
AC, you are the next.
Okay, AC Lindum, Lavin. I was just going to reply to Peter that the flex algorithm isn't an inter-area solution. So if you're doing one of these things where you need the reverse path, one use case is adding interfaces to that. Forgive me if I don't use all the right terminology, but the interfaces to the SAB table and the routes are outside the area. You don't know what the reverse cost is in the other area. So the only alternative would be to add interfaces to all on the path to all the ABRs that are advertising the prefix. So with this, you can do an inter-area reverse path calculation for those prefixes. That's the use case, and I don't believe that's covered with the existing reverse SPF because it's within a single area. I mean, this flex algorithm, reverse path algorithm.
All right, so it's Peter Pshenak. It does actually, and we can take that offline. I can show you how that works.
Okay.
Any other questions? Okay, thanks, Changwon.
Thanks.
Okay, good morning, everyone. This is Jiedong. I'm going to give a presentation of this new draft on ISS extensions for the load balancing alternates on behalf of my co-authors here. Okay, first, the motivation. We know that IGP normally computes the shortest path based on the IGP metric in the network. And the link bandwidth utilization is not taken into consideration by the IGP SPF. But if there's a link degradation or the failure, which causes the link throughput reduction, or the volume of the traffic flows increase dramatically, there can be congestion if only the best path is used for the traffic forwarding. In this kind of scenarios, it will be helpful to also calculate and enable some traffic engineering paths for the load balancing. So this document describes the ISS extensions for the computation of alternate traffic engineering paths. These paths are called load balancing alternates or LBAs. They can be used for the load balancing when the shortest path is becoming congested. Okay, here's the proposed mechanism for this extension. Basically, it follows the approach of the ASLA mechanism. A new IGP application is introduced to advertise the link attributes used for the computation of the load balancing alternates. So we just need a new flag in this ASLA attribute TLV. And this new B flag indicates that the application is a load balancing alternates. And for network which we need to enable this function, the bandwidth utilization of the network links are monitored and advertised periodically. Here we reuse the unidirectional utilized bandwidth of TLV defined in the RFC 8570. But other sub-TLVs may also be carried for other considerations or constraints in the future. For the period of this advertisement, it can be configurable, and the recommended interval is 10 seconds. Here are the operational procedures of this mechanism. And basically, according to the operator's policy, computation of this LBA path can be enabled on specific nodes in the network. Nodes which are not enabled for this functionality simply ignores this information carried in the LSPs. When for nodes on which the LBA is enabled, when the bandwidth utilization of the local link exceeds a pre-configured threshold, like the link shown here, that's a bundle link, but there's some member links, they are cut or there's failure, which cause the traffic reduction and the throughput reduction, and there's a utilization of this bundle link is increased. So in this case, they will trigger the local computation of this load balancing alternates so that they can be used, prepared to be used for this traffic forwarding. And this collected link bandwidth utilization information should be considered in the computation of this load balancing alternate paths. If in the scenarios, if this load balancing alternate path is not loop-free, which is very typical, and most of the cases, this is we may not find a loop-free path for this load balancing path. So there's we need some mechanism for the traffic engineering, or such as SRTE, to ensure there's no traffic forwarding loops. And the second stage is that when the bandwidth utilization on the local link exceeds another pre-configured threshold, the network node should steer a portion of this traffic to the load balancing alternates to reduce the congestion on the shortest path. And if there are multiple LBA paths available, the traffic load can be distributed among all these passes according to the bandwidth utilization of this LBA passes. But the detailed mechanism for the load distribution is implementation specific. Here are some considerations about this, why we introduced a new ASLA application. We know that RFC 8919 gives the considerations for the advertisement of the extended T matrix. It suggests that advertisement for these attributes is associated with all the applications utilizing the link. But for this case, because for the computation of the LBA path, the interval of this attribute advertisement can be much shorter than the interval required by other applications. That's to avoid unexpected churn introduced to other applications using this matrix. So we recommend a new LBA application to advertise these attributes only for the LBA computation. So that is isolation from other applications rely on this T matrix. Another thing is why we use IGP for this. I think we give some source considerations here. The first is we can reuse the existing IGP T matrix. We only introduce one bit. It's a very small extension to the protocol. Secondly, it can reuse a reliable and efficient flooding mechanism to collect this link utilization information for the LBA computation. The third one is, this is actually, we think, is similar to the loop-free alternate computation. It's just that we need to take the link bandwidth utilization into consideration. Okay, for the next steps, we would like to collect comments and revise draft accordingly. Okay, Tony.
Hi, Tony Lee, Juniper. Question one, back on the earlier slide, you said you were going to update link bandwidths every 10 seconds?
Yes, the utilization of the link bandwidth.
So that implies over the entire network, you're going to basically churn the entire LSDB every 10 seconds?
But it will not trigger the computation of the SPF, right?
It may not trigger SPF, but you're
Right.
certainly going to be reflooding the entire LSDB every
Yeah.
10 seconds. You think that's
Yeah.
acceptable?
Yeah, but it's configurable. If you think 10 seconds too short, it depends on your operator's policy. You can make it longer, but that may not be that reactive to the congestion.
Exactly the problem. Not being reactive to congestion is kind of pointless. Okay, I'd like to direct your attention to another draft called Tactical Traffic Engineering,
Yeah.
which is exactly this with SRTE already.
Okay, we will take a look. I remember there was a draft. Thank you.
Just answer NVIDIA. Tony, are you done? Yeah, so
Echo.
very, very similar comments. As you know, we've been supporting advertising of metrics or load into IGP for quite some time. In the beginning, we also blown up a few networks by doing it not really careful. So again, as Tony said, if you wait too long, the information is irrelevant and practically you're actually going to harm your network rather than help it. Because by the time you advertise this information, it's of no use. Probably traffic pattern has already changed, right? So you might actually reflood entire LSDB for no reason, or actually make the condition worse, right? If you do it too often, again, you're going to blow up your network. We've seen this before. And again, I would like you to point to tactical draft that does it from perspective of local node. So you don't need to flood anything. You react exactly where you observe the congestion, not trying to make it knowledge across the network, which is again really bad idea.
Okay, thanks for the comments. We will take a look at that work.
Jeff, are you done?
Yeah, thank you.
Okay, AC, you are the next.
Actually, I think I'm going to defer my comment since it's not as, it was just on how it's done now, as opposed to whether or not it should be done. I think the other ones are more important comments anyway, so.
Okay, then we'll move to Peter.
Peter Pshenak, Cisco. So your last point in that slide, you say if the LBA pass is not loop free, just please go back to the previous one. Yeah, the last point on this slide. You say you're gonna enforce this. So if there are multiple links where you are doing this local rerouting, how are you going to make sure that they don't loop? You enforce the traffic and then suddenly it hits a different path and then somewhere else in the network you are rerouting the traffic back. Are you doing enforcing hop by hop? Because that's the only way
you
how
need
can
to
see.
give an explicit path.
Yeah,
using
but explicit paths can have loose hops. How do you make sure that these don't create loops?
I mean, the explicit path will go to the destination of this.
Well, that doesn't matter. Still, it is being forwarded based on the base routing in the middle nodes.
Base routing? You mean?
Yeah.
Why we
I
use?
don't think that what you are proposing is sufficient to make it work.
I mean, we use explicit like adjacencies for this forwarding.
So you do link hop by hop enforcement.
Yeah.
How large is the stack become?
Yeah, it depends on the network. Scale of the network.
Thank you.
Okay, any other questions? Jeff, you are still in the queue. You want to say something? or you forgot to remove
No,
yourself?
thank you. I'll remove myself.
Okay. I see you do still have a comment, or we can move on?
You can, let's see here. You can move on.
Okay.
I-
Thank you.
Thank you.
I was
Thank you for-
trying to capture this before I forgot it.
Okay.
Okay. Thank you, Jie. So the next one will be me. So this is Yingzhen. I'll be doing an update of all the LSR young modules. So far we have published all these documents. And the important one is we published the extended OSPF v3 extended LSA. So that unlocks the dependencies of a lot of new features extensions so they can use the extended LSA. And we have both the OSPF and the ISS young models for segment routing on IESG telechat early next month. And these two are the last two documents that doesn't have the LSR word in the document titles. So, and another one is we have the OSPF admin tags that's also gonna be on the telechat soon. So this one is the one we try to have the young module together with the specification. Through this experiment, we do feel like later when we have drafts of a document that's the specification is relatively simple and straightforward, we are gonna enforce to include the young module in the document. Sometimes your specification in terms of the young module, you may only have like one enable command and one TLV. So it makes sense to have the young module go together with the specification. But something like the, for example, the flex algo, that might be too big to go together with the specification. We don't want the publication of young module delay the protocol extension. So we'll check this, look at this on a per document base. So most likely at the adoption phase. So if any of you have some comments about this idea, please speak up. And then we have the augmentations for OSPF base module. So far we have this many RFCs included in the document. The one I highlighted in blue are the one that recently added. We are looking at whether we want to split this document into two, because the flex algo and the bandwidth constraint, those are like relatively big. So far, this document has more than 100 pages. And I think split them into two might be easier for reviewers. And this is the corresponding one for ISS. So we have this many features. So you can clearly see OSPF have a couple more. So I will look into adding those into ISS too. So the reason I have to do it in OSPF first is because how the TLVs are defined in LSA or LSP. So OSPF does have this dependency on some previous definitions, but ISS LSP is sort of independent of each other. So. And then we have the both OSPF and ISS SRv6 young modules. So these two are sort of sitting in the back burner because we do have dependency on the SRv6 young module in Spring Working Group. That one, I haven't seen much progress on that one yet. Bruno, you want to say something about the SRv6 young in Spring? That one, because these two have the dependency on that one. That sort of serves the foundation.
I agree with you. And okay, we'll contact the others again.
Yeah.
To try to move.
Okay.
If it doesn't work, we can work offline.
Yeah, because I know that one sort of has been moving slow. So if you need some help, let me know.
Okay, thank you.
Yeah. And then we have this ISS PICs, the protocol implementation conformance statements. So far we have all these three, we have 4 modules altogether. One IANA module that defines the base, decides the features that the model can query, and the framework one that use query all the features and the detail ones corresponding to each different RFCs. This one, I think for the young module wise, it's more about the level of technical details we want to include in the module. So we really want to have feedback from service providers to see whether this module satisfy your requirements, or you want to have more details, or you want it to be coarse. Just let us know. And then this one pretty much summarizes the sequence we want to go. So we'll go the segment routing one, that since those are already gonna be on the telechat, so they will be published pretty soon, I hope. And then the augmentation one, because we have accumulate enough features. And then the peaks is sort of independent. So if we have enough feedback and the service provider are happy with it, we'll just go ahead with those. And that's all. Any questions, comments? Oh, you are welcome to take a look at the 100-page document. Okay, thank you. So we'll move to the next presentation.
Just going to say that since I'm co-author on those two large augmentations, that we think we should move forward before they get any bigger without taking on more of the features. And if we can, we might split it with Flex Algo going first and taking. But the problem is there's a lot of interdependencies in the TLV encodings.
Yes.
That makes grouping them actually better. So we're going to have to look at that. I gotta. Ying Zhen has done the lion's share of work. Now I gotta go in and look at it too.
Yeah, we most likely we may split them into 2 documents. The ISS one is fine. The OSPF one now is too big.
Yeah.
Okay, so the next presenter.
Okay. Hi everyone. Can you hear me?
Yes, please go ahead with your presentation, and you have control of the slides. Thank you.
Okay. This is Jimmy from China Mobile. On behalf of my co-authors, my topic today is flexible algorithm for energy efficiency. Okay. Currently, the rapid growth of network energy consumption has made operators pay increasing attention to the power consumption management of communication systems, and building an energy efficient network has become an important goal of the industry. To achieve the goal of network energy conservation, we should first establish a multi-level energy consumption monitoring system and energy efficiency evaluation system. And then, based on the obtained network energy consumption data, we can formulate practical measures to reduce energy consumption. During the IETF 120 and 121 meetings, the Green WG carried out several rounds of discussions on relevant topics such as the definition of energy metrics and the collection of network energy consumption. However, the routing protocol and algorithms based on the energy consumption metrics are not within the scope of this working group. That is, it is precisely the reason why we have chosen to make this proposal in the LSR WG. The Green Working Group has achieved several key results regarding requirements. It covers multi-level energy consumption collection, including which includes network level, device level, and board level. Network level energy conservation optimization. For example, tidal energy conservation and routing an algorithm based on energy consumption, and traffic adaptive power consumption adjustment, such as this means that the device dynamically shut down some components based on its own traffic level. As for use case, it involves energy efficient network management, including energy consumption monitoring and energy consumption management, progressive architecture deployment, traffic proportional consumption reduction. In the terminology system, it focuses on defining core metrics such as energy per bit and energy efficiency ratio. And these two metrics are the most frequently mentioned by the Green WG. The former is used to measure the energy consumed by a device when forwarding a unit bit, and the latter is used to measure the relationship between the total power consumption of the device and the power consumption of the heat dissipation system. When it comes to the data model, the WG has completed the design of modules such as energy consumption collection and reporting, and device energy conservation control. And based on these progressions, we believe that the mature condition for conducting research on energy consumption aware routing protocols have been met. So this draft, referring to the achievements of the Green WG, puts forward an energy consumption matrix system at the device level and interface level by monitoring the maximum real-time and average power consumption data. Evaluation of the energy efficiency of network devices can be achieved. And most of these matrices are directly related to the energy consumption per bit. And there are two modes that can be adopted for path planning based on energy consumption metrics. The centralized solution collects data through the IGP floating mechanism and reports it to the controller via BGPOS for global path calculation. Of course, in this case, each device within the domain can also report energy consumption data to the controller through telemetry. And the distributed solution broadcasts the energy consumption matrices and the constrained flex algo through the IGP protocol after the nodes within the domain filter out the inefficient links according to the preset rules. And they execute the SPF algorithm to determine the optimal path. This draft defines two categories. One is for energy consumption data notification, including ISS, OSPF, node and link level energy consumption sub-TLVs, and the other is for defining a new flex algo. The former realizes the protocol carrying of energy consumption parameters, and the latter supports the avoidance of inefficient devices by expanding the matrix types and the constraints of the flex algorithm define sub-TLVs. So the energy consumption notification TLVs include ISIS energy consumption sub-TLVs we define here, and OSPF link energy consumption sub-TLVs. And IS has node energy consumption TLV and OSPF node energy consumption TLV sub-TLV. And the definition of the new flex algo is used for calculating routes based on energy efficiency or excluding links that do not meet the energy consumption requirements. Here, multiple IGP matrix types and new flex algo constraints are defined, including ISIS and OSPF. So there is ISIS and OSPF definition of TLV. In summary, this draft proposal and energy consumption data dissemination mechanism based on IGP floating and a definition scheme for flex algo with multi-dimensional energy efficiency constraints. In the next step, we plan to update the link deletion rules list and listen to the suggestion from the working group and update the drafts. Okay, I think that's all.
Hi, Tony Lee, Juniper. I'm a little confused. Maybe you can help clarify. It seemed like you're advertising that information about your links and it's somehow tied to flex algo, but that's just static information about your topology. Why do it that way? Hello?
Hello?
Yeah. Because we want to exclude the links and the nodes that do not meet the energy consumption requirements. Is that
you can certainly constrain the topology, but the information you're distributing is independent of whether it's in flex algo or not. Let me put it another way. Could an operator use energy efficiency on all of their traffic?
I'm afraid
Okay, I'll take my answer on the mailing list. Thank you.
Yeah.
Oh, okay, thank you.
AC, you are the next.
I was just, AC Linda, I was just thinking that you're going to have to optimize on, in addition to the constraints for flex algorithm, you also have a lot of these new metrics defined. Is there another document that describes these in detail? And it seems like you'd need like a sort of a other use case on how somebody would do this optimization. I agree with Tony too. It's not apparent why you wouldn't have a global optimization strategy that maybe you were using. I don't know, maybe rather than doing it with flex algorithm for specific prefixes. More like traffic engineering, just do it with traffic engineering using the same information. Anyway, I know you're looking for input. So speaking as chair, I'd advise more people to read this and start the discussion and point to any other documents. I know there was another document. I only read the OSPF the LSR document. I didn't read the companion document. I guess Peter?
Okay, thank you. Okay, thank you. We will supplement the use case.
Shall I? Peter Pshenak, Cisco. So I have two questions, or basically one question and comment. So some of the metrics you define looks to me they are dynamic. They are not static, like the real-time consumption and all that stuff. Are they dynamic? Can you confirm that? Okay. I guess I asked at the mailing list.
Yeah.
And the second thing is the way
it
you...
depends on the strategy requirements. I think it depends on the strategy requirements, and if you can send that to the mailing list, send that question to the mailing list.
Okay, I'll do both of my comments. Thank you.
Okay, thank you.
Okay. So any more questions for this presentation? If not, any questions or comments for the whole working group? Going once, twice, and we are done. Thank you so much for your attention.
Thanks. Nos vemos en Madrid.
Yeah, we'll see you in Madrid.
Bye. See you.